everyone. Today, I'm here with a geometry problem that feels like a brain teaser. As you can see, we have a pentagon that's been painted in different colors. The question is as follows. A point selected within a pentagon is connected to the midpoints of the pentagon's edges and to one of its vertices, as shown in the figure. The resulting regions are colored differently, and areas of these regions are written on the figure in units. What is the value of A minus B? Do you have any ideas? Pause the video and try to solve it. So how should we approach such a problem? For example, let's connect the center point with the bottom left corner. We're told that the lines drawn from the center divide the sides into two equal parts. If the yellow area has an area of a square units, then the red triangle must also have an area of a square units, right? Because their bases and heights are equal. So their areas must be equal too. If the total area of the red region is 5 square units, then the other red triangle must have an area of 5 minus a square units. Now let's draw a line from the center to the bottom right corner. That side is also split into two equal parts. So the blue triangle also has an area of 5 minus a square units. If the total area of the blue region is 7, then the other triangle must have an area of a plus 2 square units. Now let's connect the center to the next corner. What is the area of the green triangle? Yes, you guessed it right, a plus 2 square units. Now let's connect the last corner. The purple triangle has an area of b square units. The other purple triangle then has an area of 4 minus b square units. So the final green triangle also has an area of 4 minus b square units, right? We're told that the total area of the green region is 8 square units. So let's add the areas inside it. 4 minus b plus a plus 2 equals 8. From here, the difference, a minus b, is 2 square units. I think it was quite an instructive problem. Were you able to solve it? Let me know in the comments. See you in the next problem.